Hi, and welcome to the video about continuity. And if you don't have continuity, then you have discontinuity. So we're going to talk about the three types of discontinuities as well. So what makes something continuous? Well, here's the definition. The graph of f of x is continuous at a certain point. We're going to call that at x equals a if the following things happen. First, the limit as x approaches a from the left must equal the limit as x approaches a from the right, and that must actually equal the value of f of a. So what does that really mean? Let's take these first two pieces. If the limit from the left is equal to the limit from the right, that means that that limit exists, right? I'm actually going to just rewrite that as the limit of f of x as x approaches a, right? Because that really means from both sides. So if the limit approaches the same value from both sides, that limit exists. And this part is saying that it's what you'd expect it to be, right? There isn't a hole in that graph, there isn't a vertical asymptote in that graph, and we can draw a picture of a graph. If you think of something that's continuous, you probably think of a nice smooth curve, like something you would draw. You wouldn't have to pick up your pencil to draw it. All right, so this looks continuous. So let's say that this is the x value of a. Right? Notice that this value right here, that's going to be f of a. And the limit from the left, the limit from the right are both the same value. They're approaching f of a, right? And that's what makes this graph continuous. So let's say that these conditions aren't satisfied. What happens? That's when you get a discontinuity. So the first type of discontinuity that we should talk about is one that you're very familiar with, and that is a vertical asymptote. We are actually going to call that an infinite discontinuity, and you're going to see why in a second. So we're going to say that there is an infinite discontinuity at x equals a if the limit as x approaches a from the left is either positive infinity or negative infinity. We also need the limit as x approaches a from the right to be either positive infinity or negative infinity. And we also need f of a to be undefined. That is shown right here at x equals 0 as a vertical asymptote. So infinite discontinuities, we're getting that name, right, because the limits either go to positive or negative infinity. So from now on, if you are asked to identify a discontinuity, instead of calling it a vertical asymptote, we're going to call it an infinite discontinuity, and we're going to give the justification by showing that these three conditions are satisfied. The second type of discontinuity is called a jump discontinuity, and that's pictured at x equals 4. A jump discontinuity happens when the limit from the left does not equal the limit from the right. And you can see that here. Right, the limit from the left, I don't know, maybe about a quarter. The limit from the right is approaching 4. But there's also this condition that both of those limits actually have a finite value, right? Because if I think back to the infinite discontinuity, one of them was going to infinity, the other was going to negative infinity. Well, that would fit this case, right? But we're saying that that's not allowed to happen in a jump discontinuity. You're not allowed to have a limit as infinity or negative infinity. They have to have a finite value. So here at x equals 4, that's exactly what happens. And the last type of discontinuity is a removable discontinuity, otherwise known as a hole. So on this graph we have a removable discontinuity at x equals 6, and here's what's going on there. The limit as x approaches a value from the left does equal the same thing, right, as x approaches that value from the right. Looks like this one is approaching 6 on both sides. But here's the third condition that makes it the removable discontinuity. It is not allowed to have either of those limits equal to f of a. Okay? So right there, we know that f of 6 is actually 4. Now, f of a is allowed to be undefined, and this would still be considered a removable discontinuity. All right, but just remember that. But this is the part that actually makes it a hole. Right? Look at the jump discontinuity. This, yeah, I guess that's reminiscent of a hole, but a hole is now really going to be defined as something that you could just erase, right, in that little spot there. Or in other words, if you filled it in with one point, it would be continuous, right? If I filled this in, this graph wouldn't be continuous. This jump is something that is going to be kind of difficult to fix if you want to think of it as fixing. All right, so I think we've covered everything. You should be good to go for classwork.